Hi everyone, and today we're going to solve the medium problem which is taken from Tinkoff DSA pool. At the first glance, this problem may seem easy for you, but don't underestimate it. A lot of people cannot find the proper way to provide the solution in optimized way. So let's start. From the definition of this problem, we have to find two max keys by their corresponding values in a dictionary. We have different keys, it doesn't matter at all, it can be different type. What matters is our values. There you can see unordered, and you can see its integers, but it doesn't matter. It may be floats. The idea is that we have to return two maximum keys by their values. In our case, this is D, B, or B, D. The order doesn't matter, but we have to return it as a list. Okay. Let's start from the beginning. What we have to do firstly, you may think that, okay, it looks easy. Wow, what is the problem? Probably there are some built-in dictionary methods which may help us to find the maximum keys. Okay, let's check it out. Let's firstly create our function. Def find two max keys in dictionary, and let's call it print and pass our D. I put breakpoint here. Let's check it out. D. What we can see? You can see that, okay, there are some built-in methods which we can use, and you can see that there is nothing related to getting max keys. Items, pop, keys, values, copy, clear, pop item, set default, update, some magical methods, but nothing related to getting max keys. Okay, you may think that if it doesn't exist, maybe this function or method exists in Python. The built-in methods or functions exist in Python. Some built-in libraries which we can use, but there are a lot of libraries, there are a lot of methods and functions, and it's very hard to tell to tell which one to use if we don't know the data. We have to find some tips and patterns in data to find out what we can use to get these maximum keys. Let's explore our data. What we can observe that our values are unordered, and it probably may seems reasonable in your brain that we need just sort our values and just take the two highest keys by these values. Okay, let's implement it. I remove our debugging mode. Let's start. Return our sorted dictionary items. Let's use not items. Firstly, you can see that it doesn't provide you the right result. Do some sorting like this, and we need something different. Let's maybe add an items here. Let's try it out. You can see that we have dictionary items provide us tuples with keys and values. As a key, as a 0 index, and value is our first index, and we can observe that nothing was sorted for us. Okay, it doesn't work because we have in sorted function we have to provide the key which we have to use for the sorting if we use tuples, and because by default we don't know what we should use for sorting, what index we should use for sorting. In our case, this is the first, this is not the first but second index. Sorry, it's index 0. Let's use 0 index and first index. This is better to avoid confusion. We have to do something like this. Remember it correctly. And let's reverse it. Right, let's reverse it. What we see that we have it's sorted. We have our tuples, sorted tuples with key value pairs. What we have to do is just take the first two tuples elements, and we see that this is our result. You can, if we will back to the beginning of the class definition, we have to return it as a list of keys and not list of key value pairs. Okay. Let's use like a sorted array. Let's write this to our list to our list going to return our 0 index of each tuple. Sorted array. Here I just return for this is our result. It works fine. This is what we want to see there. And interviewer may ask you, please provide the time space complex of this algorithm. Time complex is going to be loaded. So sorted by default considered to be O n log n with the time complexity. I understand that there are different sorting algorithms, but let's just by convention use quicksort with O n log n time complexity. And space complexity is going to be O1 because we don't allocate extra memory. Again, if we are talking about quicksort, it's done in place, so we are not taking the extra memory. O1 is okay, is right. But is it possible? Does it look for you a little bit complicated to have O n log n solution for finding two max keys by values? Yes. What we interviewer may ask you, is it possible to find O n solution? May we optimize this solution? And the answer is yes. What we have to do is just iteratively go through left to right through all our iterate over all our key value pairs and just create two max entries, where max entries is our key value pairs, and if we will encounter some values which is more than max 1 or max 2, we will reinitialize it with new values. Yeah, this is a solution. It looks fine, it looks great. It's not, how to say it, it's not as short as this solution, but it's much faster. Let's write it. For this, I will use version 1. For this, I will use version 2. 2 max keys, version 2. Again, we pass our dictionary. Space complexity and time complexity we calculate afterwards. And let's initialize our max entries. And 3, 1. Which is going to be a tuple, none with float minus infinite. Why this way? Because none is going to be our key. Firstly, at the beginning we don't have some keys, we have none. We will reset it with new value, with a new key. and the value for the max entry is going to be minus infinite. This is just a mock for us. Max entry 2 is going to be the same. Okay, let's just iterate over our key value pairs in our dictionary items, and we will check. We will have two conditions. If our value more than max entry 1, 1, because 1 is this first index, 0 index, first index. We compare with values. We have to do something. Otherwise, we check that we have a value which more than max entry 2. It's less than max entry 1, but higher than max entry 2. And yes, that's it. Let's reinitialize our max entry 1 and max entry 2. In our case, if it's more than max entry 1, then max entry 2 is going to have the value of max entry 1. It's shifted. And what was initially in max entry 2 is going to be eliminated at all. Let's define this logic. Max entry 2 is going to be equal max entry 1, and max entry 1 is going to have the key value pair. Yes, in this case, when our value less than max entry 1 but higher than max entry 2, what we have to do is just reset our max entry 2 with key value. And what we have to do at the end is just return as a list max entry 1 and max entry 2. But again, if we will just return it right now, it's going to be our pairs of key value pairs. We need only keys, so we have to specialize to set it to return only the 0 index for us, so only keys. So when we return, db is returned, and this is our solution. As I said before, time complexity of this solution is going to be on, and space complexity is going to be O1. Again, ON, because we iterate through all our dictionary, how to say it, pairs. One pair, second pair, third pair, fourth pair, and so on and so on and so on. We do it only once. So the time complexity is going to be ON. Space complexity O1, because constant space complexity, because we don't allocate extra memory at all for this solution. We allocate only two variables, which we reinitialize and reset, but by convention, but big O convention, we consider it, we remove constants and consider it as a constant space. That's it. Thank you for listening. Thank you for watching. I hope this was helpful, and have a happy coding day. Bye.